Okay, here we want to talk about definite integrals. When we have a definite integral, we do find the antiderivative, but we have to respect the upper and lower limit. So here we have 2x squared plus 6x, but we're evaluating it from 1 to 3. So the first thing we do, we want to find the antiderivative of 2x squared plus 6x. So that's going to give us 2x cubed over 3 plus 6x squared over 2 from 3 to 1. But we see that 6x squared over 2 can be reduced. So we're going to use that as 2x cubed over 3 plus 3x squared. Okay, now using the fundamental theorem of calculus, we need to evaluate this first at 3, then we subtract, then we evaluate it at 1. So first, we're going to use 2 times 3 cubed over 3 plus 3 times 3 squared minus 2 times 1 cubed over 3 plus 3 times 1 squared. Now, the algebra is going to be very important here. It's going to be very important to follow the order of operations, because if not, it can lead you into a answer that's very incorrect. All right. So 3 cubed to give us 27. 27 times 2 is 54, and 54 divided by 3 will give us 18. 3 squared is 9. 9 times 3 gives us 27. Now we move to the second set of brackets. 1 cubed is 3. 1 cubed is 1. 1 times 2 is 2. And then so that'll be negative 2/3. Don't forget to distribute this negative sign. 1 squared is 1. 1 times 3 gives us 3. So that'll be negative 3. So the first thing we do, we add up our whole numbers. 18 plus 27 is 45. 45 minus 3 gives us 42 minus 2/3. All right. So now once we get our common denominator, remember we have to get a common denominator of 3. The denominator of 42 is an understood 1. So this will give us 126 thirds minus 2/3. And when we simplify this, this will give us 124 thirds. So that's how we evaluate a definite integral. We did this one from 1 to 3. Had we did this from 0 to 2, that would have given us another answer, or from 2 to 5, or 3 to 7. But in here, it's specifically from 1 to 3. Be very careful on the algebra right here. Our true calculus is just the very first step where we find the antiderivative. After that is essentially an algebra problem. All right? So be very careful right there.